electric current, electric current, electric current. Electric current is, if we choose a conductor, these are the two ends of the conductor. The length of the conductor is what? L, or the two ends, let it be, these are connected to battery. It's a plus and minus. Potential difference is V. So when potential difference is created, potential difference is created means what? This is what V and 0. It's 0, this is what V. When potential difference is created, so the electrons, so this is what, in a positive and negative, electric field is created. Electric field is created. Electric field is created. So in the direction of electric field means what? Potential difference from the higher potential to lower potential, electric field is created. Electrons tends to move. Electrons tends to move in a opposite direction to the electric field. So like this. This can cause what? It's a drift speed. It's a drift speed, which is drift speed. Drift speed. So first one, what is electric current? I. I is equals to Q by T. I is equals to Q by T. So second, NE by T, number of electrons. How many electrons are moving? Current direction is what? Opposite direction to direction of electrons. So opposite direction to direction of electrons, I is equals to Q by T, that is equals to NE by T. I is equals to, when the electron is moving, a charged particle is moving in circular path, its radius is R, velocity vector is V. Okay, so here this T become as what? It's a capital letter T. I is equals to Q by capital T. T is what you say? It's a time period. It's a time period. So I is equals to QF. I is equals to QF. F stands for what? Frequency. Next one you speak about this. Second one is drift speed. What is drift speed? Here one more thing we can write on this. Here I is equals to dq by dt. If he is asking about dq, dq is equals to I dt. Then q is equals to what do you write? Integration over I dt within the limits. Second, drift speed, this is Vd. Vd is equals to, first one, mu into E. Vd bar mu E bar. So mu is what you say? It's a mobility. Mu is what? Mobility. So this is mobility. It's a mobility. Vd bar is equals to mu into E bar for the drift speed. Next, one more thing from this, drift speed Vd is equals to I by NEA. N is what? Number density. Okay, so number density, number of charges. Okay, number of charges per unit volume. Unit volume. Number density also we can say here, N is equals to capital N by V. When electric field is created in the conductor, acceleration A is equals to EQ by M. So now the drift speed Vd is equals to E small e and capital E by tau by M. is the formula. So you need to remember, direct question will be asking from this. Tau is what? Relaxation time. E is the charge of electron. Okay. So capital E is the electric field. M is what it's a mass. This, if I speak about, is a cross section. Through this cross section, this is what it's a J bar. J bar is, this is what is it? It's a area, cross sectional area. J bar we can say current density. Current density. Current density J bar is equals to I by A. J is equals to I by A. So from this, VD is equals to what we written? I by NEA. I by A is what? J. VD is equals to J by NE. Then J is equals to VD into NE. Next, second one, Ohm's law. Ohm's law. At a constant temperature, this is conductor, its cross-sectional area. Potential difference is created. When potential difference is created, which is connected to the battery, it's a positive and negative. This is what? Plus minus potential difference is V. V and 0. So the potential difference is created. Higher the potential difference is higher the current. V proportional to I. V is equals to Ri. So V is equals to I into R is the Ohm's law. So from the Ohm's law, when electric field is created here, this is what electric field is created because potential difference is here. The electric field direction is what? E bar. So this is current density is what? J bar. J bar is equals to E bar into sigma is another form of Ohm's law. Current is scalar, current density is vector. So J bar is equals to E bar into sigma. This sigma is called conductivity. It's a conductivity. Conductivity is sigma is equals to 1 by rho. Rho is what you say, it's a resistivity. Is resistivity. Sigma is equals to 1 by rho. Next one, from here, J bar is equals to, J is equals to E by rho. E is equals to J into rho. E means what? Electric field. Potential difference is what? dV by dx minus is equals to J into rho. Its magnitude dV. So dV means it's a V by L is equals to J into rho. V is equals to J rho into L. J is what? Current density. Current density is what? Current per area. V is equals to I rho L by A. V is equals to rho L by A into I is another form. V is equals to, this is in the form of V is equals to R into I. So what is the R? Resistance. Resistance R is equals to rho into L by A. Rho is resistivity. Rho is resistivity. Resistivity depends on what? It depends on temperature. Depends on temperature. Resistivity does not change while changing the parameters. So its length and cross-sectional area of the wire. It's a intrinsic property of material. Resistivity rho is equals to, means it depends on temperature. So rho T, it's a temperature. So that's what rho is equals to. Rho naught into 1 plus alpha delta T. Alpha is temperature coefficient of resistance. Temperature coefficient of resistance. So one more condition is asking, at constant temperature, at constant volume, volume is constant. For the question, particularly for the NEET point of view, at constant volume is recasting of wire. Recasting of wire. Otherwise, stretched wire. At that condition, we need to use R proportional to L square, R proportional to 1 by A square, proportional to A means what? Pi R square whole square. It's another help box for, so stretched wire, for the stretched wire, for the recasting wire. Verification of Ohm's law. In the verification of Ohm's law, circuit diagram for the verification of Ohm's law, first we have a resistor, ammeter is connected and connected to a battery, and key is closed. So one voltmeter is connected to measure the potential difference of given resistor. Its potential is V. This is the potential plus and minus. Potential difference is V. Usually current flows in this way. Voltmeter reads potential difference, current, ammeter reads current. Here, first one, as increasing the current value increasing, the potential difference gradually increasing. So for the different type of conductors was proved experimentally. That is, for the first case, when we use this, it's a VI graph, potential difference versus current graph. So the graph is linearly for conductors, non-linearly for semiconductors. So which obey Ohm's law are called ohmic conductors, which do not obey Ohm's law are called non-ohmic conductors. So if we choose about from this any 2 points on this is the current is, it's a delta I. Here it's a delta V is potential difference, it's a delta I. So this makes an angle theta. So tan theta is equals to delta V by delta I. So delta V by delta I, for the V is equals to IR, V is equals to IR, R is equals to V by I. So R is equals to delta V by delta I. The slope of VI graph, this is what it's a slope of VI graph, R is equals to, so that's what slope of VI graph. When temperature increases, resistance of a conductor increases. One more point we can say, when temperature increases, resistance increases. This versus, for example, it's a temperature for the different graphs will be given. So, like, then what do you say? For example, if I use this here, it's a V versus I. Okay, so two graphs are mentioned. Its angles are theta 1 and theta 2. This is temperature T1 and T2. Whose resistance is more? Whose slope is more? Whose slope is more? The temperature is more. So that's what T2 is greater than T1. So slope of VI graph gives what? Resistance. This condition is for ohmic conductors. For ohmic conductors, we can say like, next one is for non-ohmic conductors. Non-ohmic conductors. For non-ohmic conductors which do not obey Ohm's law. Non-ohmic conductors, two types of graphs we can get it. Two types of graphs. One is increasing slope. Next one is what? Decreasing slope. So increasing slope and decreasing slope. This is V versus I. It's a V versus I. When slope increases, resistance also what happens? Increases. When slope decreases, so resistance gets what? Decreased. For the fourth one, combination of resistors. Combination of resistors. First one, series combination. Series combination. Next one, parallel combination. Parallel combination. For series combination, when resistor are connected in end-to-end connection, like, so you can choose two or more resistors. If you want to use one more, you can use this. This is, so a battery is connected. Potential difference is created. It's a R1, R2, R3. Positive and negative potential. It's a V1, V2 and V3. Current flows in this direction is okay. First one, I remains constant. Next one, potential is distributed, V1 plus V2 plus V3. So equivalent resistance R series is equals to R1 plus R2 plus R3. For n number of resistors, for n, capital N number of equal resistors, n number of equal resistors, Rs is equals to n into R. Potential difference of each resistor is equals to V by N. Potential difference of each one is what? V by N. So one more condition you can say on this. Here V is varying, V is equals to IR, so I is constant, V proportional to R. So this is what V1 is to V2 is to V3 is equals to R1 is to R2 is to R3. Same as if you want to write V1, V1 is equals to V times of R1 by R1 plus R2 plus R3. Similarly, V2, V3 also we can write. For the parallel combination, two or more resistors are connected. So we are choosing about three resistors are connected in parallel combination. Potential difference is created like it's a V. Resistance R1, R2, next one is R3. Positive and negative. Current flows like, so it can split like I, this is I1, it's a I2, this is I3. It's a I1, I2 and I3. So what changes here? First one, potential difference is same. So V is equals to constant. So V is equals to I is distributed. I is equals to I1 plus I2 plus I3. I is equals to I1 plus I2 plus I3. So V is equals to IR, then I is equals to I proportional to 1 by R. It means R equivalent is equals to 1 by R parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus so on. Similarly, here RS is equals to R1 plus R2 plus R3. Next one, for n number of n number of equal resistors, n number of equal resistors, 1 by Rp, that's what Rp is equals to R by N. The current of each one is equals to, what is this? It's a I by N, such a most important things. This V is equals to IR, I proportional to 1 by R means what? I1 is to, I2 is to, I3 is equals to 1 by R1 is to 1 by R2 is to 1 by R3. If you want to know I1, I times of 1 by R1 by 1 by R1 plus 1 by R2 plus 1 by R3. Similarly, you can write I2 and I3 also. Resistance due to, so radially outward conduction. Here one thing we need to remember, rho remains constant. Rho remains constant. Okay, rho is changing from point to point, but rho is remaining constant. So next one is coaxial cylinder. Coaxial cylinder. For the coaxial cylinder, I'm choosing about, here is the cylinder for inner and outer radii are mentioned. This is the axis of cylinder. Its radius, first one is A, next one radius is, it's a B. So the conduction occurred in between what? These two surfaces. Conduction occurred from here like inward to outward. So we need to choose, for this situation, we need to choose a small element, cylindrical element is the small element. Okay. So like either sides we can use. So this length from here to here I am taking as x. This part is what it say dx. Limits from where A to B. So dr is elemental resistance. Elemental resistance. dr is equals to rho into L by A, rho into L by A, dr is equals to rho into L means what? Dx by A, dx by A. So, A is the surface area. This is what? Surface area. dr is equals to rho into dx 2 pi RL means what? XL. L is what? It's a length. Total resistance R total is equals to integration over dr is equals to integration over rho dx by 2 pi XL limits from A to B. R total is equals to, so rho by 2 pi L is outside, integration over dx by x limits from A to B. R total is equals to rho by 2 pi L integration over dx by x is what? Log x limits from A to B, log B minus log A. So this is R total is equals to rho by 2 pi L log B by A is the next one. So this is what? Total resistance for the radially outward, so coaxial cylinder. Next one, resistance when resistivity changes. Resistivity changes. When resistivity changes, resistivity is what? Rho. I'm choosing a rod, that's what? Conductor, creating some potential difference, is connected to the battery. Now its length is L. So with respect to length, the resistivity gradually changing. This is X and Y I am talking. So when resistivity changes, when resistivity rho changes, you would be given some expression rho is equals to, it means what? Rho of X or rho naught of X. With respect to X, resistivity changes. When it changes, we need to divide into that infinite length elements. When you divide into the infinite length elements, any one from these you can talk on this. This is what resistance is dr. Dr is what? Elemental resistance. This thickness, this length is what? Dx. The length from here to here is, you can say, as a x. Now, resistance dr is equals to rho into L. L means what you say? It's a dx by what? It's a rho into L by A, cross sectional area is what? A only. A, so it's not changing. It's not changing this. So this may be rho as a function of x, rho not of x if you talk on this. R total is equals to, we can say, R total is equals to, all these resistors are connected in series or parallel, series combination. So R total is equals to R series is equals to, that's what. So integration over dr, this we can say. So integration over rho naught x into dx by its length. This is the cross sectional area is what? A. So now we can talk on this. R total is equals to, so integration, okay, integration over from 0 to L, rho naught times of x dx by A is the answer for when rho is changing with respect to length. Next condition, if we use about, there is now if it is, its length is what? This is the height y. Okay. So same, now we can use this. It's a potential difference is x and y are created from here to here. If you divide into the length elements means, if we divide into the length elements, this is what a length element is taken. Okay, small portion from this. So now we can write this is, it's a width, this is width, this is what? It's a dy. Okay, what is its length? L. The length is what? It's a L. Now I want to write about elemental resistance is, elemental resistance dr is what you say? It's a dr. So you know the formula, R is equals to rho into L by A. dr is equals to rho, rho is varying. L is what? This is what you say? It's a dy. By area means what? What is the area of this? Length into breadth. So this is, so length is what is, it's a W into what? Area. Area I'm taking as like. Okay, you can write its area is, so W into dy like. Now here this is dr is equals to rho into dy by A. A means what? Its area we need to find. All these, which one is that? All elements, that's what? Length elements. Length elements are connected in a parallel, are connected in parallel. Then what is this? 1 by R total is equals to 1 by dr. 1 by R total is equals to 1 by, so that is what? Integration over, so 1 by, what is this? Rho into dy by A. So this will become as A by rho into dy. So rho is changing with respect to what? It's a position. That's what? Rho of y. Some value would be mentioned. You need to go for integration. So limits from where? 0 to some height h, otherwise y is the condition. This is parallel combination. So this type of questions will be asking for JEE mains. It's not for the purely NEET students. Okay. Equivalent temperature, equivalent temperature coefficient. You know, temperature coefficient is alpha. Two resistors you have, they are connected in series. Its resistance is R1 and R2. Temperature coefficients are alpha 1 and alpha 2. This is what, it's a series combination. These two become as like a equivalent. So it's what R equivalent and alpha also equivalent. Directly we can write alpha equivalent is equals to alpha 1 plus alpha 2 by 2. If we have 3, alpha 1 plus alpha 2 plus alpha 3 by 3. So for the parallel combination, first resistor R1 coefficient, temperature coefficient, so is alpha 1. Next one is R2, temperature coefficient is alpha 2. This is X and Y. So is equivalent resistor is, so this is what R equivalent. Next one is alpha equivalent. Alpha equivalent is equals to alpha 1 plus alpha 2 by 2 for the series and parallel combinations. For seventh one, Joule's law. And electrical energy and power. First one for Joule's law. Work done in different cases is directly proportional to heat produced. W is equals to JQ. J is the Joule's constant. Electrical energy from V is equals to W by Q. V is the electric potential. So W is equals to V into Q. So for the first one, W is equals to V into Q means what? IT, because I is equals to, what is this? Q by T. Q is equals to IT. For the second one, W is equals to I square RT, because V means what? IR. So two important relations. So next one is electric power. Electric power P is equals to electrical work done per, so time, rate of electrical work done. So first one is P is equals to VIT by T. TT cancel. What is this? V into I. Next one, P is equals to I square RT by T. T and T cancel. What is this? I square R. So these are the relations for electric power. Power is measured in watt. So electrical energy is measured in kWh. So that is what? 3.6 into 10 power 6 joule. Next one. So power dissipation. Power dissipation means what? When power is dissipated, when resistor is presence. Where resistor we have this. So that's what power dissipation is equals to I square R. In place of I, V by R means what? V square by R. So two relations we can use it. Eighth note is Kirchhoff laws. Kirchhoff's laws. KCL and KVL. For the first one, KCL, which is Kirchhoff's current law. Kirchhoff's current law. So what is the use of this conservation of charge? Conservation of charge. For KCL, if we use a junction, sum of entering currents and leaving currents is equal to 0. So this is what it's a node or junction. It's a I1, I2, I3, I4, I5. I1 minus I2 plus I3 plus I4 minus I5 is equals to 0. This is called KCL equation. Algebraic sum of all the currents at a junction is equal to 0. Directly, he won't ask us any question like what is KCL like. So, how to use this for the KCL? I'm taking about example 1, such very important for the problem solving for all the levels. If you have, there is a resistor, next one is another resistor. Okay, so next here is connected. It's a X and Y potential difference. It's a 4 ohm. This is 6 ohm. This is 3 ohm. So I would be asking on this, what are the currents? The question will be, what are the currents? Currents through 4 ohm, 6 ohm, 3 ohm. What are the currents? For example, here 30 volts, here is the 0 volt. Now we need to apply at the X. So from here, this check it as what is the potential difference between these two? Just to take it, this is the high potential. High potential means what? So it's what? X minus 30 by 4. Next, X minus 0 by 6. Next, X minus 0 by 3 is equals to 0. So after getting the value of X, we can get it as I1, I2, next one is what? I3, all the values we can calculate. Okay, so is a way of calculation of this. In the same continuation, Wheatstone bridge. So for the Wheatstone bridge, balanced condition, balanced Wheatstone bridge, unbalanced Wheatstone bridge. First one I'm talking about balanced Wheatstone bridge. Balanced Wheatstone bridge. So what is the balanced Wheatstone bridge? Generally, first one, these are the resistors are used here. So when do you say the circuit is balanced or not? It's a P, next one Q, it's a R and S. P, Q, R, S. Okay. So first current passing through here, I. This is what I1. This is I2. Next one is I3. Next is what? I4. Here another resistor is connected. It's what? This, for example, some what is that? It's a G galvanometer resistance. If I1 is equals to I3, same current is passing. I2 is equals to I4. Okay, then potential, this is what? A, it's a B, C and D. Potential at C is equals to potential at D. Potential at C equal to potential at D means what? No current, no current flows through what? Fifth resistor. Fifth resistor. No current flows means what? It can be removed. So this can be removed for what? For balanced condition. So when it is removed, then these two will be what? So it become as first the circuit is here like is the case. So it's a P, and next one is Q, this is R, next one is S. Okay, is the condition. These two are in series. Next one, these two are in series. These two will be in a parallel. We can find on this. Sir, what is the R equivalent? R equivalent means what? It's a P plus R. This is Q plus S. So A and B are parallel means what? A into B by A plus B. Like R equivalent is equals to, we can write, what is this? P plus R, okay? P plus R into Q plus S by P plus R plus Q plus S. This is for balanced condition. Sir, what do you say about unbalanced condition? See, these two, for condition for the balanced means here PS is equals to QR. PS is equals to QR. For the second one, if it is, this is for balanced. PS is greater than QR. So what is this? It's a unbalanced. PS is, this resistance is more, its resistance is less. Potential at D is greater than of potential at C. Current flows from where? So current flows from D to C. Current flows from D to what? It's a C. So next, for the third case I'm talking as this, QR is greater than PS. QR is the product of these two. QR is greater than PS. So current potential at C is greater than potential at D. Current flows from where? It's a C to D. This is called unbalanced. Unbalanced condition is what? Potentials are not equal. Either VC is greater than VD, VD is greater than VC. So when potential is not equal, then how do you solve such type of question? Okay, so we are using on this unbalanced Wheatstone bridge is, I'm choosing as this is what unbalanced Wheatstone bridge. If I take 2 ohm, 2 ohm, it's a 4 ohm, 4 ohm. So in middle one is, it's a 6 ohm. Current flows I. This is I1, I2. 4 ohm I1, I2, no? Here I2. Here is what? I1. Total I comes out. Again the question is about, so if you want to check about is it balanced or not, 2 by 4 is equals to 4 by 2. Is it possible? Not possible. 2 by 4 means what? 1 by 2. 4 by 2 means what? 2 by 1, which is not possible. That is what? Unbalanced condition. So we need to use that. So what is that? So first one I'm talking as this. It is connected to, for example, 100 volts potential difference, plus and minus. This is 100, this is 0. 100 and 0. You can choose now to find the I1 and I2. We can take about this is X and Y. Use the KCL, same like earlier. Careful on this. X minus, this is 100, means what? Here 100 only, no? Correct? Yes. So X minus 100 by 2 plus X minus 0, 0. X minus 0 by 4. Next one, X minus Y, X minus Y by 6 is equals to 0. This is my first KCL equation. For the Y, if you write Y minus 100 by 4 plus Y minus X by 6 plus Y minus 0 by what? 2 is equal to 0. So first this is the Y minus 6, okay, by 6. Y minus 10 by 4. Next one, Y minus 0 by 2. So solve the equations, you will get, so what is this? X and Y values. By using this, we can get it to what? So like terms should be eliminated from that. So we can get the I1 and I2. I1 and I2. Sir, what do you want from this equivalent resistance? Sir, to find the equivalent resistance. For the equivalent resistance is what? V is equals to IR. R equivalent is equals to V by, so I. R equivalent is equals to what is the V here? 100 by I. I means what? I1 plus I2. Total current, no? I1 plus I2. Sir, I get it as I1 from this. This is I1. I1 means what? Like, what is this? Y minus 0 by 2. What is I2? I2 means what? This. What do you say? X minus 0 by what it say? 4. This is I1 and I2. Is a way to use about KCL equation. So for unbalanced Wheatstone bridge means what? Like we can use the KCL equations. Infinite ladder circuit. Infinite ladder circuit. Another model. So infinite ladder circuit. If you have many resistors, so it's what? Like this infinite ladder circuit is the ladder from this. So up to infinity. The links will be continued up to infinity. The values are, so this is 3 ohm, 2 ohm, 3 ohm, 2 ohm, like this. Everything is a case. It's X and Y, otherwise A and B. So you can choose from this which part is repeating. This part is repeating. You can choose the locate some 2 points on this. What is the equivalent resistance of this total? Let it be X. Equivalent resistance of total is what it say? X. Okay. So here 2 terminals we have that. Its potential difference is what it say? V. So now I'm taking as this is okay, like we have the 2 points. This is P and Q. This is R equivalent. It's a 3 ohm. The potential difference, the equivalent resistance of the total circuit is what? Let it be X. This is 3. This is what is here? 2. Now remaining part also will be is what? Also will become as what it's a X. So what is the R equivalent? These two are what? It's in a parallel. 2 into X by 2 plus X. R equivalent is equals to 3 plus 2x by 2 plus x. R equivalent is what? X. X is equals to 3 plus 2x by 2 plus x. You will get a quadratic equation. So then x is equals to minus b plus or minus under root of b square minus 4ac by 2a. So according to the options, we need to choose it. Method of symmetry. Method of symmetry or symmetric circuit. For the method of symmetry, any circuit is given. For example, if you have the circuit is this, like. So method of symmetry, all the resistances are, I am taking this. Okay. We can use that folding method. Folding method. Or what is that? Next one is about detaching method. Okay. So method of symmetry, we can use it as this. Folding method or detaching one. Any one for the problem solving is the same. Now I'm using this. For the first one, this is X, this one is Y. I'm asking what is the equivalent resistance between X and Y. So what should I use? First one, which is a mirror. Mirror means what? Which is the most symmetric on this. This is what? Just a line joining of X and Y. Perpendicular bisector of this is what? Symmetric line. It's a symmetric line. Symmetric line has same potential. Same potential at every point. Same potential at every point means what? Here potential, this potential, this potential, this potential. Potential difference is what? 0. So potential difference is equals to delta V is equals to 0. Here what to do? The resistors along with symmetric line can be ignored or removed. So if you remove this, then what? We have the resistors like, so this is okay, is our situation. It's X and Y. These are removed. So it's what? R, 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 R. Everything is R. Then you can find the equivalent resistance. These two are what in series? These two are in series. Three of them will be in a parallel. So it would become as what? 2R, correct? This is 2R. Yes, this is 2R. So R equivalent is equals to 2R by 3 is what? Method of symmetry. Circuit analysis. Circuit analysis. It means circuit containing two or more batteries. Contains two or more batteries. Current through 4 ohm resistor. Current through 8 ohm resistor. Current through, it's a 2 ohm resistor. He also may ask about what is the potential at the junction. Potential at a junction. These are the possibilities of question. Now, here for the problem solving, you can use about KVL. We can use about KVL, Kirchhoff voltage law. But circuit analysis model, it's based on by using KCL, such a simple one. I'm doing this. So first one, this is 10. Here is the potential is 10 volts. This is negative. Means what? From 10, 20 will be removed. So that's what? This potential will be what? 10 minus 20 is minus 10 volts. Let it be your common potential at the junction is X. X, this is what? It's a positive. Means what? Addition of this. Here potential is what? X plus 10. X plus 10. So while applying the KCL, you need to think about this is the point from here all the currents are moving away. So sometimes current will be towards here now. You may get negative sign. Negative sign means what? Our assumption is wrong. The direction will be changed. Here, first one, I'm using KCL. KCL is what? I1 plus I2 plus I3 is equals to what? 0 at the given junction. Here now I'm talking as this. This is high. Means X minus of minus 10 by 4. V by R. I equal to V by R. Plus X. So this is there. Now between these two I need to find it. What is there? X plus 10 minus 20 by 8. This. Next one. X minus 5 by 2 is equals to what? 0. So now you can simplify on this. Here, while taking this is what? X plus 10 by 4 plus X minus 10 by 8 plus X minus 5 by 2 is equals to 0. We can take the value of X. So while taking the LCM on this, okay, we will get the value of X. After getting the X, we will get the current in this. That is what? I1, okay, I2, next one I3 can be calculated. Is the method. So just what? How to use the KCL? You will get it as X is equals to 10 by 7. You will get X value is 10 by 7. Okay, after getting this X, you will get, so the currents, and next one, already you got the potential. How can you find the current on this? By using KCL. use the KCL condition. This is the point here. Let it be x. So this, let it be, this point is what? It's a 0. It's a grounded, just to imagine. This is 0 means this one also 0. 0, from 0, 10 will be added. 10 will be added. What will be this? It's a 10. 0 plus 10. If it is, for example, minus, from 0, 10 will be deducted. 0 minus 10. Here x, 10, 20 will be added. X plus 20. This one is also x plus 20. Yes. Now apply KCL. For the KCL, first one is what? X minus 10 by 10 plus x minus 0 by 10 plus x, okay, x, what is there? So this is the cell, correct na? Cell we cannot use. Where to use here? Between these two. What is that? X plus 20 minus 0 by 5 is equal to 0. So is the method. So to find about, just you can go for the calculation. It's a multiply with a 2. Okay. So this is what? X minus 10 plus 2 times of x plus 20 is equals to 0. So it's a 2x minus 20 plus 2 times of 2x plus 40 is equals to 0. 2x plus 2x is 4x. So 40 minus 20 is plus 20 is equals to 0. Okay. So this is what? For x is equals to minus 20, x is equals to what? Minus 5. So if you have here, this is what? It's a minus 5. Okay, minus 5. So the x value is minus 5. This will become as what? Minus 5 plus 20. What will be this? 15. Here also 15. What is the current? Let it be, current is what? Just I'm taking as it's a I1. Okay. So direction all are away from this one. I'm taking I1, next one I2, next one I3. Sir, if I want to know about I1, this is the I1. I1 means what? V by R. Okay. So V means what? 10 minus. Correct na? 10 minus. Potential difference is what? 10 minus of minus 5 by what? 10 is equals to I1. So 10. So then what is this? 10 plus 5. It's a 15 by 10 is equals to I1. This is what? 5 2s are, 5 3s are. I1 is equals to 1.5 ampere. Okay. So for next one is about, just if we talk about this one, what is there? X minus 0, minus 5 minus 0. Correct na? So then what? I2 is equals to what? I2 is equals to minus 5 minus 0 by what? 10. Minus 5 by 10. So what is this? Minus 0.5. Okay. So next one, if you think about this one, so what is there here? This is the current, correct? So is the current. So then what will be the current here? X plus 10 minus 0 means x means what? 15. So I3, I2, this is I2 now, this is I3. So I2 is equals to, then what? 15 minus 0 by what? It's a 5. So what is this? It's a 3. 15 minus 0. So by 5, it's what? Like a 3. This what is battery? What is battery? Okay. So battery is, first one we talk about this. What is the EMF? EMF of a cell. EMF of a cell is what? When a circuit, okay, so when a circuit is open, it's what? Open. The potential difference between the terminals, of a battery of a, so battery is EMF, electromotive force. So when you talk about this, a battery, just battery is taken as this is what like a battery is chosen. You know already cell and battery, a group of cells is what it's a battery. So its EMF is E, its internal resistance is what, small letter R, let it be, the potential difference is what, it's a V. Yes. So in the first case I'm talking on this, it's what, charging. Okay. So charging of a cell. Charging of a cell. So for the charging of a cell is what, when this is the, so the cell is given. Yes. Now it is, the current is going into the cell. This is, its EMF is E, and internal resistance is what, small letter R. So what is the potential difference? So this is V is equals to E plus IR. V is equals to E plus IR. IR is what, potential gradient is added. Next one is, so discharging of a cell. Okay, so discharging of a cell, discharging of a cell. So for the discharging of a cell is what, when this is the cell is taken. Yes, so current is flowing out away from this. So its internal resistance is what, this is the internal resistance, it's a small letter R. Potential difference V is equals to, what is this, E minus IR. So this is the condition. So if it is charging, so V is equals to E plus IR. Discharging means what, V is equals to E minus IR. So IR is what, potential drop. Combination of cells. For the combination of cells from this, there are two conditions we can say. One is series combination. First one is series combination. Next one is about parallel combination. So parallel combination. So for the series combination, first one cell is given. This is what, like, and I'm using that internal resistance is R. Next one more cell is given. Its internal resistance is what, small letter R1. So this, its EMF is E1, this is what, E2, it's R1, next one is R2, the terminals are X and Y. So its equivalent will become as, equivalent is, this is what, it's a like a equivalent of these cells. It's what, X and Y. So what is the E equivalent? E equivalent is equals to E1 plus E2. And R equivalent is equals to, R equivalent, both of these two are in series. What do you say? R1 plus R2. So in the series combination, so series combination means like this, we can mention as this. So E1, X and Y equivalent, we can write it. In the parallel combination, first one cell is there, this, its internal resistance is what, like, next one is about, this is what, here is the parallel combination. Its EMF is E1, next one is E2, internal resistance R1, and another one is what, R2. So one more condition I can say my here, these two, one is what, positive, its internal resistance R1, next one is, so this is, the cell is reversed. So reversed means what, like its internal resistance is this. It's a R1 and R2. So its EMF is E1, next one is E2. So both of these are effective equivalent EMF next internal resistance. So it's what, X and Y. So now I can say E equivalent is equals to E1 minus E2 because both are connected with the opposite terminals. So R internal, R equivalent is equals to, however, same the thing. What is this? R1 plus R2. So for the next one, here both this is what it's a X and here is what Y for the parallel combination. So these two are became as a equivalent. Next one, so equivalent EMF. First I'm taking about. So equivalent EMF, next internal resistance is R, like this is what X and Y, yes. So this is what E equivalent, next one is what R effective or R equivalent. Such a very, very important relation. So many times this model was there. Okay, so when they are connected in parallel combination, so what is the equivalent resistance? So here E equivalent is equals to E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2 is the relation. So equivalent EMF is what? This is a condition you need to remember. And what is the R equivalent is what? R1 R2 by R1 plus R2, because both of these were connected in parallel. So what is the equivalent EMF is E1 by R1 plus E2 by R2 by 1 by R1 plus 1 by R2. When cell is reversed, so cell is reversed, then sign changes. Okay, sign changes. Sign changes. And next one for the grouping of cells. In the grouping of cells are, so n number of identical cells are connected in a series. So identical cells means what? First cell, next one its internal resistance is there in inbuilt. So just what I'm not drawing this. So like this is what n number of identical cells. It's what X and Y. Its EMF is what? E and E. Everything is what? E. This we can say as, okay, internal resistance is R, and everything is R. How many times? N times. So it acts like a single one, then I can say as this is what, like a individual, its internal resistance is small letter R. So E equivalent is equals to what do you say? N times of E. Its internal resistance is what? R equivalent is equals to N times of R. If the same situation is connected to the external resistor R, okay, external resistor. So here is, this is the branch. So set up like it is connected to an external resistor R. This is what external resistance. Its EMF is E, and everything is what? E only. Okay, so it would be treated as like this. So this is what like, and its internal resistance is what? R, and external resistance is what? Capital letter R. So this is what? It's a E equivalent. This is R equivalent. E equivalent is equals to what? NE. R equivalent is equals to what? NR. This is external resistance is capital letter R. So what is the current passing through this one? I is equals to E equivalent or E effective by R total resistance. So I is equals to, we can write E equivalent is what? NE by, so R plus, what is this? NR is the relation for series combination. Parallel combination of cells. So for the parallel combination of cells, if you have, so this is what? These identical cells are taken like a parallel combination. So these are connected in what? Parallel grouping of the cells. So parallel grouping like. So this is what here its EMF is what? E everything. This is what E we can write. Its internal resistance, it's there inbuilt only. Just for understanding, I'm drawing this. It's what? R like. So it will be treated as, this is what? It's a X and Y. Yes, it will be treated as. So this is a cell like next one, effective resistance. Okay. So like just I'm talking on this. It is X and this is the Y. So E effective, E equivalent is equals to E, and R equivalent is equals to what? All of these resistors are connected in what? What? 1 by R equivalent is equals to 1 by R plus 1 by R plus so on. It's what? N by R. So this become as what? R by N. Okay. So then this is here E equivalent, because EMF remains same when they are connected in parallel combination. If the same setup is connected to the external resistor means what? This is what here is mentioned, and it is connected to the external resistor. So this is the R, and next one is its EMF is E. This is E effective, it's what? E, and R equivalent is equals to what? R by N. So now we can write on this, the current I is equals to what? E effective by R total. So E effective is what? It's a E by R total is R plus internal resistance R effective. So this is E by, okay, R plus R by N. So small r by N, it's a small letter R by N. So this is what? NE by R plus NR plus small letter R is the relation. So for the mixed grouping of cells also we can use that. So mixed grouping of cells. So when mixed grouping of cells. So for the mixed grouping of cells, n number of identical resistors, cells are connected. So in a series, like this branches many are repeated. N number of identical cells are connected in series, so they are repeated. How many times? N times. How many branches you have? M branches we have here. So this is what like, so is the condition, and this is just to imagine, it's what connected to the external resistor R. This is R. So it has its EMF is what? E, internal resistance is small letter R, E and R, everything is what? E and R. How many times? M times. Let it be, this is I'm taking as this small letter N times. It's what? It's a N times. So this would become as like a singly, these all are grouped as one in the series, would be taken as this, and internal resistance is R. So what is its EMF? NE. It's a NE. What is the equivalent resistance? All the resistors are connected in series combination. What do you say? NR. So like this is what it say. So NE, next one NR. R connected in what? It's a, so it's a NE and NR. So these all are connected. So to the what is this? Parallel combination. Now these again all are grouped. Okay. So grouped means what happens? So this become as a one. Next, okay, it's a resistor, and external resistor R is like this. NE, all these are connected in what? It's a parallel. Equivalent EMF is what? NE only. NR. How many times? M times. Okay, what is the equivalent? NR by M. What is the resistance? Total resistance is what? R. R plus NR by M. So current I is equals to E effective by what? R total we can write it. So these are the formulae based on what? Current electricity. So one more is there. It's based on Wheatstone bridge. Wheatstone bridge, and next one, extended form of Wheatstone bridge is what? Meter bridge. So meter bridge has the same condition, but we use the term is what? Balancing point. Okay. So P by Q is equals to R by S only.